So we have seen that there are various ways to classify the different kinds of tests that are done on equipment. There are the standard test and the special tests. Of these standard tests, some are routine, some are type test, some are only done under special situations. So just to get an idea of what kind of standard tests are done on power equipment, the first is accelerated aging on insulating systems. I'm not going to talk about this right now because we will spend quite some time on accelerated aging test a little later in this lecture. Apart from accelerated aging test, we have a large collection of tests which are intended to measure specific insulation properties. We have, of course, talked about disruptive discharge or breakdown tests, which have to be done on any material before we can actually deploy it for insulation. But apart from that, we often use tests which are not directly related to the dielectric breakdown, or may not even be directly related to dielectric properties, but some specific insulation properties, some specific properties of the material which may be electrical or non-electrical properties. Most of these tests are done on materials. Sometimes they also have to be done on systems. So we have to differentiate between insulation systems and insulating materials, where even though the insulating materials are okay, when you bring them in conjunction into a system, you might face specific problems. What are the high voltage tests to be done depends on the nature of the equipment to be used or the system being tested. For example, to give you some examples of tests you wouldn't do in any case on any insulation, but are very specific application dependent. One is the aberration resistance test to select material for slot liner. In rotating machines, you have conductors sitting in slots on the rotor, and we need insulating materials to line the slots. Now, in this case, of course, it has to be an insulating material, but apart from that, there are other things that we need to take care of. When these conductors are loaded, they carry high current. These conductors can expand. The coefficient of thermal expansion of the conductor material will generally be larger than the coefficient of expansion of the surrounding insulating material, the lining material. So as a result, what happens is there are shear forces due to unequal material expansion due to loading, due to high current. There will be shear stresses between the two materials. Also, there can be aberration between the two materials because of mechanical rotation. And therefore, one of the tests that you would have to do for any material that's used for the insulation, for the slot liner, is an aberration resistance test, which you would not have to do normally for every insulating material. Then tracking resistance of material for end winding of high voltage stators. So when you have high voltage stators, the end windings often are subject to tracking. Normally, we do tracking tests for outdoor insulators, but in this case, even inside a rotating machine, even for material to be used in a rotating machine, we might have to do tracking resistance tests. So there are always some specific tests which might be necessitated by the particular application in hand, apart from the regular tests that you do. Some of the standard tests which are not so very application dependent, which we more or less do on most power apparatus, are short time dry wet withstand flashover test, where you check the flashover of the material of the insulator over a short time in dry conditions and in wet conditions. Induced over voltage withstand test, impulse voltage withstand test, and this impulse voltage withstand test can be full wave or chopped wave, because chopped wave can result in high impulses. So there might be some breakdown mechanisms which are relevant to chopped wave, even if the full wave can be withstood. Time delta measurement, that's your loss measurements, temperature rise measurements, electrochemical measurements, mechanical, puncture, that's your dielectric breakdown, porosity, because porosity can be important in terms of the water the material absorbs. If a lot of water is absorbed, the material may lose its insulating property. Aging studies, pollution studies. Pollution studies, of course, mostly for outdoor insulators, but not necessarily just for outdoor insulators. These standard tests and procedures are defined by international and national standard bodies for each specific equipment or system component, and we just have to abide by the standards. For example, just to take a look at a couple of such standard tests, we consider the impulse, lightning or switching Withstand level. If we are talking about self-restoring insulation, remember we always differentiate between self-restoring and non-self-restoring insulation, because one is a destructive test, in the other case the same test will not be non-destructive. If you have a self-restoring insulation, 15 impulses of rated voltage and of each polarity are applied. 2 disruptive discharges are permitted. So we are setting up here a pass-fail criterion. It's not that the moment you have a failure, you consider the material to have failed. You need 2 breakdowns to consider the material to have failed or the insulating system to have failed if you apply 15 impulses of either polarity. Or that is one way. The other way is to find out the 50% flashover using either the up and down method or the extended up and down method. Determine what is the 50% flashover and check that, compare that with what you have designed for. In test of non-self-restoring insulation, you cannot allow two breakdowns. So, and you also do not want to run the risk of 15 breakdowns possible. If you have 15 impulses, 15 breakdowns are possible. You do not do that. Instead, you have 3 impulses. 3 impulses are applied at the rated withstand voltage level of a specified polarity. The insulation is deemed to have withstood if no failure is observed. So in this case, you're subjecting a material to a fewer number of tests, but you're also giving it lesser leeway. The moment one failure happens, it is failed. So these are some differences. Here are some examples of material property tests and the standards that are related to them. I'm not going to read out all of them. For example, D14981 test method for dielectric breakdown voltage and dielectric strength of solid electrical insulating materials at commercial power frequencies. Then test methods for AC loss characteristics, for permittivity, test methods for conductance, test method for high voltage, low current, dry arc resistance, test method for tensile strength. So again, this is a completely non-electrical property. Then there are methods for testing film insulated magnet wire, detection and measurement of partial discharge. This is something we will discuss in greater detail. Dust and fog tracking, voltage endurance, partial discharge, liquid containment, inclined plane tacking, and erosion of insulating materials. So these are some of the material property tests that we routinely do. There are many such other tests. The standards organization which are generally setting up these standards, which are generally engaged in setting up the standards, are the IEC, which is the International Electrotechnical Commission. This is the most recognized body. Then you have ANSI, American National Standard Institute, or you have IEEE. So we have standards from each of them, and depending on the application, we might use any of them. Next, we shall talk about one important class of test, that is the accelerated aging tests.